All right, so we're going to do a little review of complete the square first. So if I had x squared plus 6x equals 16, and I wanted you to solve by completing the square. Okay, when I complete the square, I want a couple different things to be set up first before I start. I want all of my x's to be on one side, so I have x squared and x on the left side. All the numbers to be on the other side, 16 is on the right side. And I want the number in front of my x squared to be 1. So I have 1x squared, so I'm good. Okay, so now that it's in that form, I can do my b divided by 2 squared. So I get 6 over 2 squared, which is 3 squared, so I get 9. Okay, that's going to be the number that I add to both sides of the equation. So I'm going to have x squared plus 6x plus 9 equals 16 plus 9. When you do that, this should be set up as what we call a perfect square. So if I factored, I would have something times itself on the left side equals 25. So it would factor into x plus 3 times x plus 3. Now it's set up so I can do what I call the square roots method. I can take the square root of both sides, write plus or minus. So I'm going to have x plus 3 equals plus or minus 5. And then I subtract my 3 over, so I get x equals negative 3 plus or minus 5. And those are two nice integers. Those are numbers I can figure out. So the first one is negative 3 plus 5. So I get 2. And the second one is negative 3 minus 5. So it's negative 8. So those are my two solutions. I'm going to try a couple more. All right, so let's try a square root one. So let's try x squared minus 2x minus 2. So the first thing I want is all my x's on one side, all the numbers on the other side, so I'm going to add the 2 over. So now it's in that form I want. So I'm going to do my b divided by 2 squared. So I take my negative 2 divided by 2 squared. So I get negative 1 squared. So I have 1. That's going to be the number that I add to both sides of my equation. Okay, so now I have something squared equals 3. If I factored, I would have x minus 1 times itself. Notice that number is right here. It's what you had before you squared it. So x minus 1 squared. Now you're ready to take the square root of both sides. So I get x minus 1 equals plus or minus the square root of 3. So I get x equals 1 plus or minus the square root of 3. And that's your answer. Now if you go back to that last example, with the last example you could have gotten things on both, like on one side of the equation, and you could have factored. It would factor into x minus 8, x plus 8 times x minus 2. So when you set each piece equal to 0 and solve, you'd get negative 8 and you'd get 2, just like we had. But the difference on number 2 is that one doesn't factor. If you try to factor x squared minus 2x minus 2, it's not going to work. So complete the square is going to work for everything. It works for square root answers, it works for answers with I, it works for everything, not just those nice rational numbers. All right, let's try one more. Let's try one with fractions. I know you guys love fractions. You do. Okay, so let's do 8x squared plus 18x equals 5. So the x's are already separated for us. They're already on the left side. But I don't have a 1 in front of my x squared. So I want this to be a 1. So I'm going to divide by 8 everywhere. So when I divide by 8, I get x squared plus 18 over 8x equals 5 over 8. 18 over 8 reduces, they're both even numbers, so that's 9 over 4. So I have x squared plus 9 over 4x equals 5 over 8. So now it's in that nice form for us, the x squared and x. Okay. So this is the number that I'm going to divide by 2 and I'm going to square. So I always say have it and square it. So if I'm having it and squaring it, I'm going to do 9 over 4 divided by 2 squared, which is 9 over 4 times 1/2. Right? I didn't want to do 9 over 4 all over 2 because it's kind of confusing. That's called a complex fraction. It's a weird fraction. Okay, so I have 9 over 8 squared, so I get 81 over 64. That's the number that I add to both sides of the equation. So I'm going to have x squared plus 9 over 4 x plus 81 over 64 equals 5 over 8 plus 81 over 64. Okay, so I'm just adding from that step. Okay, if you're really good at the complete the square, you guys know that when you've done this method, you have x plus, and that number can always be found when you divide it by 2, so before you squared it. So it should be this number right here, 9 over 8. See how 9 over 8 times 9 over 8 gave us the 81 over 64. All right, and then over here, this is kind of messy. I need to combine those two fractions, so what do I need to do? Yeah, you need a common denominator. So this first one needs to be multiplied by 8 over 8. So now I'm going to have 40 over 64 plus 81 over 64, which ends up being 121 over 64. Now you can take the square root of both sides and write plus or minus. So you get x plus 9 over 8 equals plus or minus, and you just take the square root of the top and the bottom. So square root of 121 is 11. Square root of 64 is 8. And really the biggest error I see people do on these problems is at this point right here. You have x plus 9 over 8, so a lot of people will just solve it and say, okay, well x equals 9 over 8 plus or minus 11 over 8. But you guys see my error? Yeah, you need to subtract the 9 over 8 over. You need to do the opposite sign. So make sure that's the opposite sign of what it was before. All right, so now your two solutions. The first one is negative 9 plus 11 all over 8. So you get 2/8, which is 1/4. And the other one is negative 9 minus 11 over 8. So it's negative 20 over 8. They're both divisible by 4, so it's negative 5/4. So those ones can be a little time consuming with the fractions. Make sense though? Good? All right, so the whole reason I wanted to do one of these fraction ones and kind of review complete the square is because we left off last time when we didn't do the proof of the quadratic formula. So I wanted to show you that quadratic formula. I used the word proof. Some of you guys turned and looked. It's not geometry, I promise. Proofs don't always have to be statements and reasons and all that. All right, so on section 6.5 at the very beginning, we have this kind of proof laid out. Now, in the past, I put this on the test, and I put these steps on there to kind of give you a little guide of what you're supposed to do. I've also had it as a bonus without the steps. So I might put it on the test and give you the steps. I might put it on the bonus and not give you the steps. All right. So how is the quadratic formula related to completing the squared? So you guys learned this formula last time. Remember, you learned it to a very cool song. Negative b. All right, so we're going to start with ax squared plus bx plus c equals 0. I'm going to do it over here. So those steps are kind of off to the side if you need them. So I start with ax squared plus bx plus c equals 0. And I'm going to complete the square to solve for x. So when I complete the square, I want all of my x's to be on one side. I want the number to be on the other side. So I'd have ax squared plus bx equals negative c. And I don't like that a being out front. I always divide by whatever that number is. So I'm going to divide both sides by a. So already I have x squared plus b over ax equals negative c over a. Okay. So usually I will always write b over 2 squared. All right, halving it and squaring it. But it's kind of confusing because you already have b over a. So it's like you're taking that b over a, dividing by 2, and squaring it. So that's what we're going to do. So we're going to do b over a. I'm going to divide by 2, and then I'm going to square that number. So that's the same as b over a times 1/2 squared, which is b over 2a squared. So square the top and square the bottom. So you should have b squared over 2a squared? What do I write? 4a squared. 2a times itself, right? So b squared over 4a squared. That's the number that you're going to add to both sides of the equation. So I'm going to have x squared plus b over ax plus b squared over 4a squared equals negative c over a plus b squared over 4a squared. So we know that we've completed the square for a reason. So now I should have something squared. And remember that something is what you always had before you squared up here. Okay, so I should get x plus b over 2a. Now on the right side, I want to get common denominators. So the first one, the negative c over a, what do I need to multiply by? 4a over itself, right? So I'm going to have negative 4ac all over 4a squared plus b squared over 4a squared. So I got common denominators. Okay, so I have x plus b over 2a squared equals this right side, that's a b, not a 6. This right side is now b squared minus 4ac. Sound familiar?
Whoa.
We're getting there. I'm rocking your world with this complete the square into quadratic formula. All right.
I'm good.
We're almost there. All right, now what? What's your next step in completing the square? Yep, square root. So square root of both sides, write plus or minus on one of the sides. So I get x plus b over 2a equals plus or minus. I'm going to take the square root of the top, and I'm going to do the square root of the bottom. Well, that square root of the bottom is just 2a. Okay, notice how I left a little space there. What is my next step? Yeah, subtract the b over 2a over. And our very last step is we have common denominators. They're both over 2a. So it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's it. Quadratic formula. That's how they got it.
That's crazy. You mean it's not just some random numbers?
It's not just random numbers. It's amazing. They came up with it.
That's crazy.
All right, so try that on your own a couple times at home. It will make sense. You just got to see it a couple times, and then you'll have it down. So it'll be easy on the test. All right, so we did all the different things with quadratic formula. Do you guys remember those? So we did all these. Remember the discriminant? Discriminant is b squared minus 4ac. That's the part under the square root. Okay, so let's go to the very end of 6.5 where we have a summary. So this is kind of a summary of all the things that we've done from 6.1 to 6.5. Okay, so the first thing we learned was called the graphing method. Okay, so that allowed us to solve something like x squared plus 4x plus 3 equals 0. If I wanted to find when it's equal to 0, I just find when it intersects the x-axis. So at these 2 points right here. So the parabola equaled 0 at x equals negative 3. and x equals -1. And those are your two answers. Okay, that method was kind of annoying, you know, sometimes we were really far from the axis and we were getting really big numbers. It wasn't fitting on our grid, remember. So we talked about how it's nice to find the axis of symmetry first when you're graphing. So then once you get 1 point, you're really getting 2 points. All right, then we did the factoring method. So some of you guys like the factoring method because you have it down. Some of you guys still don't like it.
Wait, isn't that x squared minus 4x?
X squared minus... no, because it would factor into x plus 3 times x plus 1. Is that what you're talking about? So when you set each piece equals 0, that'd be negative. I see what you're saying. All right, so when I'm factoring this next one, this one's kind of a tricky one. I always put this on factoring sections. So it'd be x plus... I'm hearing 6, 1, 2s, and 3s. All right, think about it. The last numbers need to multiply to be 6, and your outer and inner need to combine to be 5. Nope, they got to be the same sign because they need to multiply to be positive 6. See why I always use this? So x plus 2, x plus 3. So I get x plus 2 equals 0, x plus 3 equals 0. That's called the zero product property. You have two things multiplied together makes 0. So I get x equals -2 and x equals -3. Okay, so that's the factoring method. So the next thing is what I call the square roots method. So it's when it's already set up, so it's something squared equals a number. So you can just take the square root of both sides, write plus or minus. So you'd get x minus 5 equals plus or minus the square root of 16, so 4. Add the 5 over, so you get 5 plus or minus 4. So x equals 9 and x equals 1. Those are your two answers. So 5 plus 4 and 5 minus 4. Okay, then we came to the complete the square, which we just did. So if I do my b divided by 2 squared, I get 6 over 2 squared is 3 squared, which is 9. That's what I add to both sides, so I have x squared plus 6x plus 9 equals 10 plus 9. That's now a perfect square. It's x plus 3 times itself equals 19. You can then solve it just like the square roots method. So you should get x plus 3 equals plus or minus the square root of 19. So x equals -3 plus or minus the square root of 19. So those are two answers, -3 plus square root of 19, -3 minus square root of 19. All right, and then the last one was the quadratic formula. So your quadratic formula, a is 5, b is -7, c is -8. Those are the coefficients in front of your x squared, x, and no x. And it's always -b plus or minus the square root of b squared minus 4ac divided by 2a. So I get -7, so positive 7, plus or minus -7 times itself, so 49, minus 4 times 5 times -8, all over 2 times 5. So let's see, 49 plus 160, so 209. So 7 plus or minus the square root of 209, all over 10. And 209 is prime. It doesn't go down any further. I think it's prime. Maybe 11 goes into it. I think 11 does go into it. Will you guys check? 209 divided by 11. 19. So then those are both prime. So it wouldn't break down anymore. Makes sense. So that's as far as it goes. Thank you. All right, so that's the end of 6.5. All right, we are going to look at 6.6 today too. So let me stop this.